I'm honoured to be able to speak to you today. I'm one of the technical founders of Darktrace, and as John said, I spent a long time in GCHQ and MI5 beforehand, where I was responsible for building and defending the networks. So, like many of you that work in technical security, I know exactly what it feels like to get attacked. At Darktrace, I am lucky enough to look after the R&D teams. I think this is a wonderful job in part because I don't have to get up at 4 a.m. like Taran does. And really the point of this presentation today is I want to share some ideas of what we're up to at the moment, but really I want to ask you a question that maybe we could discuss during the rest of the day in the networking breaks, or you could drop me an email or something. Really I want to share with you what we've been working on and gain a steer from you about how some of these ideas might impact your business going forwards. Specifically, I want to talk about machines making autonomous decisions to fight back against in-progress attacks. What I mean by that is we have got better and better at detection in the industry over the recent years, but we haven't particularly made life easier for incident responders. We generally invest in a lot of technology that finds stuff that's unwanted, and then we get to the point where we dump it on some poor human being and say, fix that and don't interrupt the business while you're doing it. And I have a feeling we can do better than that. And I also think it's really important because while we're in a skills crisis situation, relying on putting more and more pressure on human teams to do cleanup and incident response doesn't feel like it's going to scale out. There's a very quick bit of background about Darktrace if you're unfamiliar with us. We are primarily interested in handling incidents that are already in progress before they become a crisis. We all invest in static defenses and defenses based on knowledge of prior attacks, and they do a great job at keeping most problems out. But when problems do get inside, they often go unnoticed up until the point where you hit crisis point. Maybe systems start going down, maybe you get a visit from the police or a serious organised crime, or probably more likely that the newspapers let you know that there's been a major problem. So Darktrace's entire focus is complementing that. How can we spot these problems as they're escalating and handle them before we get to crisis point and try and get to security as a routine process? We use an immune system analogy, and it's not pure marketing. The immune system in our biological, in us as biological beings is based on the idea that we can learn our normal self and recognize in-progress attacks because they don't look like the normal self. And that's exactly what we do with this idea of a digital immune system. Learn about every device and person, how they relate to each other, the relationships between them, how they communicate with the outside world, how they use data. And if someone or something starts behaving strangely, then you can identify that and start to do something about it. Of course, it's really important that this doesn't just apply in the kind of traditional networks, but it really goes wherever your digital architecture goes, whether it's manufacturing, nuclear power stations. Increasingly, we're all using things like O365 and SaaS services like Salesforce, and many of us are moving to cloud or hybrid cloud models as well. This concept needs to go absolutely everywhere. And actually, I'm nerding out enormously at the moment because we're just about to get Darktrace into space, which I am unreasonably excited about on swarms of microsatellites. And this is great. This really works. Here's an example of what we call intuitive visual storytelling. If you want to interact with an AI system, you want to do it in your language, your technical language, your security language. You don't want to have to go and get a PhD in statistics in order to use it. So we use a lot of visual storytelling showing what was happening before, during, and after incidents in near real time, within about a second or two of real life, so you can get a sense of why the system is concerned about particular behaviours. This incidentally is a corporate espionage attack against a well-known high-tech West Coast firm. Sorry, it's a little bit fuzzy on this screen. What we're seeing here is a workstation in the middle that happens to be a laptop. They've been infected off-site, maybe on Starbucks Wi-Fi or at the airport, or they clicked on something. As soon as they reconnect to the network, the system is aggressively hunting for certain types of product information, research information on some unreleased products, even goes after some pricing information. Definitely something you'd want to know about if you were in this business. And once you've realised that this is going on, pretty simple to respond to. In fact, in this case, they didn't do any clever forensics. They just went and turned that machine off. This latter piece of connectivity here that's just arisen, really interesting, because this machine is a piece of shadow IT, not something that was recognised by the corporate teams or the security teams. Turned out to be a storage environment cobbled together in a lab by some researchers who didn't want to go through corporate change control and fill any paperwork in. A story we'll all recognise, I think. And these types of approaches find all sorts of things. You may have heard us chattering about a casino getting hacked by an internet-connected fish tank, luxury goods companies having their logistics centres robbed by someone hacking the fingerprint scanners that was meant to do access control, law firms being surveilled by people hacking into the video conferencing unit so they can hear the conversations between lawyers and their customers. All sorts of things go on, and of course the indiscriminate stuff that we all see every day. And it's great that we're getting better at catching this stuff, but then someone's got to go and deal with it. And exactly how does someone respond to a hacked video conferencing unit if they've never thought about that in the past? And what are the chances that your incident responders know how your fingerprint scanners work in the first place and how to react quickly on the bit that's strange and unusual while not shutting down all of your fingerprint scanners across the whole of the business? What I think we need is to move to a position where the machines are doing more incident response for us, where we're getting to a place where our businesses are safe by default. And there's a lot of conversation running at the moment about orchestration systems or workflow systems where we can tell the machines, hey, if this happens, you should do this, 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 and this, and all these steps. But the problem with this is it's a lot more work. We still have to have a ton of resources that actually know what our processes are and imagine the things that would go wrong and then can imagine every step of the playbook in order to fix it. Now, there are some benefits to this if you are at huge scale. If you're at JP Morgan or someone else with deep pockets, then you can get rid of a whole class of incident response work, go all the way to cleanup and have machines smashed and rebuilt from scratch in a completely automated way. But you do really need to have deep pockets, and I don't think that is where most of us are. So I'm very interested in a more middle ground. Can we get to the point where the systems just make decisions for us to resist the unexpected, the strange and the unusual, and buy us human beings time to be able to respond? This is particularly important if you're in a 9x5 environment or a 7x7, whatever, that the machines can sort of have your back out of hours. So if the finance director clicks on some ransomware, you don't come back to a smoking wasteland digitally the following morning. So how's this going to work? Well, crucially, what we can't make is really limited no-context decisions. You can't have a system say, hey, this sysadmin's just tried to connect to me, he's not or she's not done that before, I'm going to stop it. We need to recognise that there are things like sysadmins and security teams who do new things every single day, but generally behave like that. Also, you don't want to be stopping someone from going to a website for the first time. We've got to be smarter than that. We've also got to make decisions based on groups of behaviour and behaviour in all sorts of different parts of our global environment. None of us has a single system anymore. It's unlikely any of us has a single data centre. Even if we're in the cloud, we're probably in many regions. So we've got to recognise that technologically, behaviours will be shifting all over the globe all the time, and the business is relatively dynamic. Of course, we need to not just be shutting down on single anomalies either. Thank you, John. If we've got just if I come to work 10 minutes late in the morning, I don't want to find I can't log in anymore, and we have to react very quickly. But that's okay. Modern machine learning and AI is getting us to the place where we can do all of this. But I think what I feel very strongly about is responses should be very surgical. It's no good saying, hey, Dave's got some weird beaconing out of his laptop, let's quarantine him from the network. What I really want is the weird behaviour to get interrupted and stopped, but I'm still able to operate. Otherwise, all we're doing is stopping me from working, and I'm going to get straight on the phone to the help desk, and it's now someone else's problem to get me back to work. So we've got to be very surgical, and that's okay. Machines don't get bored. They can do things at a very detailed level, maybe stop an individual connection millions of times per minute if they need to, but still keep an eye if the threat starts to change or evolve. If something starts switching from beaconing to lateral movement to ransomware or sending spam, we can evolve the controls that are applied to it on a step-by-step basis using some of these ideas. And this really works as well. Here's an example of that working on ransomware. Some ransomware starts, someone's clicked on something inadvisable. Within a few seconds, this should go green, get a little squiggly line around it. There's no longer any threat to the rest of the business from this ransomware. And the user right now could probably still send emails, browse the web, etc. Eventually that ransomware will take out the laptop. But if it was something less insidious that wouldn't take out the laptop, probably they could remain infected but safe in the network for an indefinite amount of time until the security team can get around to cleaning things up. And that allows them to modernize without critically being involved in urgent firefighting all the time. Maybe we can finally get rid of that Windows XP stuff that we never have the time to fix, or get rid of some of those old and out-of-date things that we have. But playing whack-a-mole with these attacks one at a time isn't good enough. We also need to be able to respond to campaigns that hit our organization. Especially if it's coming from spear phishing, you can get to the point where yes, the first victim, patient 0, got infected, they're having an impact inside of your environment, but we automatically want to realize that this is a new attack, it got through our existing defenses, let's look back through every other employee's email and see if there are similar ways that attacks are getting hidden in there. Probably 10 or 100 people were targeted at once. Let's automatically remove the risk and those attacks from the similar emails. So yes, we have to clean up patient 0, but we don't have to do that 100 times over. This is a really ugly job. Email incident response is horrible. It involves people reading your email, so it has some data protection and privacy issues. And obviously, disrupting 100 people is a lot worse than just disrupting 1 or 2 if something slips through. None of this is about replacing the static defenses that we all have. This is about buying our security teams time and lifting them up the value chain so they can really modernize and have an impact in our businesses without having to do the grunt and the grind work. And the question I would love to talk to anybody about for the rest of the day today, if you catch me, is what else in your security teams and your security processes would you, in the ideal world, like to be autonomous? I'm lucky enough to look after our R&D roadmap with some colleagues. We're really shaping our thinking about where we take some of these ideas next. So if you have any thoughts or problems or things that you are very frustrated about in your security processes, I'd be delighted to talk to you about it. If I don't meet you in person, my email is dave@darttrace.com. Very simple, dave@darttrace.com. Shoot me a note. I'm genuinely interested. Talking to you all is the only reason why I'm prepared to get out of my windowless dungeon in Cambridge. And I look forward to meeting as many of you as possible. Thank you very much.